Exercise 6.2, question 4, part 4. You have to solve the equation sec x equals -3, x is between 0 and 360 degrees. So rearranging this, 1 over cos x equals -3, cos x is equal to -1/3, and then working in degrees, remember we want to use cos minus 1 or arc cos of -1/3 to see what we get. So inverse cosine of -1/3 gives you 109.471 ... So looking at different ways of solving this, you may decide you want to sketch a trigonometric graph, in which case we've got 0, 90, 180, 270, 360 on our x-axis, and our cosine function looks a little bit like this. Now we are solving cos x equals -1/3. So if we draw in a horizontal line at -1/3, we see a point of intersection here and a point of intersection there as well. So this point of intersection here is 109.47 degrees. So the other point of intersection, which is here, can be found by doing 360 take away 109.47 degrees, which gives us a second answer of 250.528 degrees. So this gives us a pair of answers, which are x equals 109.5 degrees and x equals 250.5 degrees, both answers to 1 decimal place. Now, using the cast diagram, well, we still have to start with cos x equals -1/3, and then x equals 109.471, etc. So let me draw 4 quadrants. And we know all the functions are positive, sine is positive, tan is positive, and cos is positive. But we're not solving for cos being positive, we're solving for cos being a negative value. Now, cos is negative in this quadrant here and this quadrant here. So of course you can see that the first answer is 109.47 degrees like that. So if we then reflect that down into the other quadrant, which is here, then we can see that the other angle is calculated by 180, and then we add on this value over here. Now, this value here, theta, in that gap there, we can see that theta is equal to 180 minus 109.47, which is equal to 70.528, and then our angle, which takes us, if I just highlight it again, all the way around there, is 180 plus theta, so x is equal to 180 plus 70.528, and that takes us to 250.528, etc., which we've seen before. Alternatively, you could look at the fact that your first answer, I'll highlight it in orange, is the same as this angle here, which is 360 minus 109.47, which of course is still 250.528. We saw that previously. So we have got to complete a trigonometrical proof. I'm going to start with the left-hand side of this, as it's much easier. It's a sort of a difference of two squares type structure, and it's much easier to break the left-hand side down by factorising it than it is to try and build up the right-hand side. So always start with the side that looks more complex. Now, this factorises, it's a difference of two squares, sec squared theta minus tan squared theta, sec squared theta plus tan squared theta. So there we have it. Now we know that there is an identity that tells us that 1 plus tan squared theta is equivalent to sec squared theta, which means that sec squared theta minus tan squared theta is equivalent to 1. So of course this is equivalent to 1. So we know that the left-hand side is equivalent to sec squared theta plus tan squared theta, which is of course the right-hand side, which completes our proof. So exercise 6.3, question 4, part 1, sine 2 theta equals 0.6. 2 theta is sine minus 1, 0.6. And we're working in radians, so please make sure you reset your calculator when we do this. So this gives me 2 theta, remember we're working out values of 2 theta, equals 0.6435 ... So I found a value of 2 theta, not a value of theta. I'll find my values of theta a little bit later on. I'm going to find all the appropriate values of 2 theta. Remember, we're finding values of 2 theta which we will halve, so yes, the question has a range which goes from 0 to 2 pi, but we have to go all the way up to 4 pi in order to make sure that we account for all answers. So here's the sine curve drawn from 0 all the way up to 4 pi, and we're solving sine 2 theta equals 0.6. So I'm going to add to my sketch diagram a horizontal line, which is y equals 0.6, and then each intersection gives me a value of 2 theta. So there's one there, there's another one there, one here, and one here. And I have to use the periodicity or the symmetry of the graph to find out each value of 2 theta. So remember, this gap here is the same as this gap here, is the same as that gap there, and is the same as that gap there. And in each case, that gap is equal to 0.6435. So this tells me that 2 theta, we know, equals 0.6435. That's one option. We've then got, and that's at point A. Then point B, I'll label it over here. That's where 2 theta is equal to pi minus 0.6435. And then point C, which is over here, 2 theta is equal to 2 pi plus 0.6435. And then we've got one final one over here, D, where 2 theta is equal to 3 pi minus 0.6435. We simply then work out each value of 2 theta and then divide by 2 to get our correct answers, which are values of theta. So we'll just finish off by working out the values of theta. Now we know there aren't going to be any more solutions, because if we continued the graph like that to get another intersection, this next intersection, which is over here, is after 4 pi. Just be clear here, this is a 4 pi. Looks a little bit like 2, but it's not, it's 4 pi. And so any values after that, when you divide by 2, will be larger than 2 pi, so too large. Now, all of this can also be done with the cast diagram. So let's sketch the quadrants, put them in place. Here we go. So remember, all the functions are positive. Sine is positive, tan is positive, and cos is positive. Now we're solving sine 2 theta equals 0.6, so we're looking for the sine value to be positive. So we need to be in the upper parts here. So the first answer that of course we get here is our value of 2 theta, and we end up with 2 theta equals 0.6435. So if we reflect that over into this quadrant where sine is still positive, we then have to work out this value here, which is why we get 2 theta equals pi minus 0.6435, because of course this value here is pi. To then get any subsequent values, we've then got to do a full cycle up to 2 pi, and then we've got to go back round to this value here, which is why we then have 2 pi plus 0.6435. Then to finish off, the last answer will take us all the way back round to here, and at that point we've reached 3 pi here, which is why this blue angle is 3 pi minus 0.6435. So there are a lot of nice ways of approaching this question. We have to show that this part here, cosec squared theta minus 1 over cosec squared theta, this expression is equivalent to cos squared theta. So many different ways of doing this. I'm going to divide both parts in the numerator by cosec squared theta, which gives me 1 minus 1 over cosec squared theta, which then gives me 1 minus sine squared theta, which we know is equivalent to cos squared theta, using the fact that sine squared theta plus cos squared theta is equivalent to 1. Now, the question then asks us to do the following. It then says to us, hence solve for cosec squared theta minus 4 over cosec squared theta equals 3. So on the left-hand side, we've clearly got 4 bracket cosec squared theta minus 1 over cosec squared theta equals 3. So we now know, of course, that this is this, and it's equivalent to cos squared theta. So this then gives me 4 cos squared theta equals 3, which gives me cos squared theta equals 3/4. So that then gives me 2 options. I'm going to clear a little bit of space to explore these 2 options a bit further. This then gives me cos theta equals √3 over 2, or cos theta equals negative √3 over 2. And we're solving for 0 to 2 pi. So we just have to solve these equations. So checking that we are working in radians, inverse cosine of √3 over 2 gives us, of course, theta equals pi by 6. And we then have to find our other answer to this, which is theta equals 2 pi, take away pi by 6. Using a trig graph, we can work that out quite easily. So it's 11 pi over 6. Cos theta equals negative √3 over 2 gives us an answer of 5/6 pi. And again, you can get the second answer by simply doing 2 pi take away 5 pi by 6, which then gives us an answer of 7 pi over 6. And those are our 4 answers. Pi by 6, 11 pi by 6, 5 pi by 6, and 7 pi by 6. So theta equals, or theta can take any of these 4 values.